ax squared plus bx plus c equals to 0. This is a quadratic equation since the highest power is 2 and a, b and c are constants. Okay, all familiar with this equation? Saw it before. Now, let's take a look at typical type of questions in your textbook, page 37. Okay, example 1. Solve 3x squared plus 5x minus 2 equals to 0. Is this of the form ax squared plus bx plus c equals to 0? Yes, right. Where a is equal to 3, b is 5, and c is negative 2. Can we solve this? Can we solve this equation? That means I want to find the value of x. Yes, right. What method do you know? Factorization, or the cross, or the multiplication frame or grid. So show me how you do it. Okay, this is just a recap. Over here I will end up with 3x squared and negative 2 and 5x. So 3x, x, 2, 1. You get 6x, x. Since I want a total of 5x, I put a negative sign here. So now I check. 3x times x, I get 3x squared. Negative 1 times 2, I get negative 2. Negative x plus 6x, I get 5x. This is our factorization, isn't it? Therefore, we get 3x minus 1 times x plus 2 equals to 0. Okay, at this point in time, is there anybody who doesn't know what I'm doing? Okay, let me rephrase the question. Who is familiar with this step? Raise your hand. Who is familiar with this step? What I've done? Raise your hand. I need a response from everybody. All know what I'm doing, huh? Okay, very good. Then I can move faster. So from here, we know that 3x minus 1 equals to 0, or x plus 2 equals to 0. Yes? X equals to 1 over 3, or x equals to negative 2. Right? That's it. Simple recap. Now I want you to try it too. Try it too now. Solve the equation. 9x minus 1, x minus 2 equals to negative 7x minus 2. Okay? You should have 9x squared minus 12x plus 4 equals to 0. Okay, after rearranging, you should have this. Then from here, use your factorization. If you don't have this, that means you made a careless mistake somewhere. It's the one made a careless mistake. Okay, after this step, we do our grid. We are expecting 9x squared, 4 over here, and negative 12x. Okay, so for 9x squared, you know that you can try the different factors. Probably a combination that will work is 3x times 3x. We get 9x squared. On the other side, perhaps I'll try 2 and 2 to get 4. When I multiply them, I will get 6x over here, 6x. This does not give me negative 12x. So what I need to do is to introduce a negative sign over here and over here. Negative 2 times negative 2, you get 4. Alright? All learned before in lower sec, right? So this gives me 3x minus 2 times 3x minus 2 equals to 0. Yes? Anybody lost? Okay, then next step. 3x minus 2 equals to 0, or 3x minus 2 equals to 0, right? Then somebody may be wondering, why you want to write the same thing 2 times? Waste time, isn't it? Is this a repeated answer? That is where we hear the word repeated roots. Okay, we'll talk more about repeated roots next time. So there are two answers, but the two answers are the same. They are repeated. Okay, so therefore, x will be equals to 2 over 3. That's it. Okay? Any questions? Okay, that's all for the recap. Then your homework. Why? What's wrong? Am I going too fast? Alright, okay, exercise 2.1. We have question 1A, J, 2B, C, F, and question 4. Simple recap questions by 22nd of Jan. I'm going to count. So, do you have a lot of time to do it? A lot of time, right? Okay. Can I move on to the next topic? Okay. Do you prefer, let me give you two equations. Consider x plus 3 squared equals to 2. This is my first equation. And my second equation, x squared plus 6x plus 7 equals to 0. Okay, two equations over here. Which one do you prefer to solve? Which one do you prefer to solve? If I give you a choice, solve. You want to do question 1 or question 2? Who chose question 1? Who chose question 2? Oh, okay. So many people choose question 2. How are you going to solve question 2? Factorize? Would you like to try it? Okay, try factorize question 2. Let's try this question. Factorize it. Are you sure? Why are you showing me your calculator? Factorizing doesn't need calculator. Are you using some shortcut? Do you know what is happening when you do that? If you don't know what's happening, you better not use it. Okay, so try factorizing it. Can factorize now? Let's see. The grid x squared, 7, and 6x. So obviously this must be x and x. Oh, 7 is a prime number. I don't have a choice. It has to be 7 and 1. So over here I get x and 7x. Okay, looks good. Hey, wait, but 7x plus x, do I get 6x? Can I put a negative sign here? If I put a negative sign, then I do get 6x, right? But if I put a negative sign here, then there will be a negative sign over here. If there's a negative sign over here, then 7 times negative 1 will be negative 7. So can it be factorized? It cannot be factorized. Then how? How are you going to solve question 2? Okay, let us look at question 1, okay? Don't skip questions unless you really think you're spending way too much time. Let me tell you a secret. Actually, these two questions, they are equivalent. Do you realize it? Do you realize that from equation number 1, if you were to expand it, x squared plus 2 times x times 3 plus 3 squared equals to 2. Therefore, x squared plus 6x plus 9 equals to 2. Therefore, x squared plus 6x plus 7 equals to 0. Do you realize they're the same equation? Same equation, right? But is there a way that we can solve equation number 1 easily? Let's take a look. Over here, I have a perfect square. Perfect square, okay? So, for equation number 1, x plus 3 squared equals to 2, right? Can you tell me how much is x plus 3? How much is x plus 3? Is it just square root 2 or is there a plus minus? Plus minus, right? Does it look very easy to solve now? Easy? Easy, right? Just take square root on both sides. So from here to here, square root both sides. Then x will be equals to negative 3 plus minus square root of 2. So there are two answers, which is negative 3 plus square root 2 or negative 3 minus square root 2. Correct? And if you were to use your calculator, whichever method that you know, you realize that the answer is correct. Can? So now, let me ask you the same question again. Do you prefer to solve equation 1 or equation 2? How many of you prefer to solve equation 1 now? All you need to do is to just square root both sides. How many of you still prefer to do equation 2? Cannot be that because you can't solve equation 2 by factorization. So sometimes we will encounter these type of equations which you cannot factorize. Wouldn't it be great if you can find a way to move from equation 2, get it into an equivalent form in equation number 1, and then we just simply take square root on both sides. If we can do that, then we can solve many other quadratic equations, isn't it? Okay, who is lost already at this point in time? Nana? Okay. So let me give you some examples of completed squares. For example, x plus 4 square equals to 9. Easy to solve or not? Easy to solve? Square root both sides. X plus 4 equals to plus minus square root 9. X equals to negative 4 plus minus square root 9. Can solve. What about another perfect square? X minus 3 square equals to 5, for example. What do I need to do to solve for x? Square root both sides. X minus 3 equals to plus minus square root 5. X equals to 3 plus minus square root 5. Easy? Okay, so now we have a reason to change our quadratic equations to look like this. Because once we get this form, it is easy for us to solve. Follow me so far? Okay, so this is the reason why we want to do something like this. Let's consider some simple numbers, okay? Square numbers. Okay, let's assume that I give you 4 identical squares. 1, 2, 3, and 4. 4 identical squares. Can you use 4 identical squares to form a big square? Can or cannot? Can, right? What will the square look like? Isn't it like this? Yes? Okay, what if I give you 144 squares? Can you form a big square? Can you form a big square with 144 squares? Yes. How much is one side? 12 and 12. So we call these square numbers, right? These are square numbers. What if I give you a number that is, for example, I give you 7 small squares. 1, 2, 3, 4, 5, 6, 7 small squares. Can you form a big square? Cannot. Who can? Who can form a big square? Cannot, right? The best I can do will look like this. There'll be a hole, isn't it? Right? I can arrange and then there'll be a hole, right? What is the number here that I should put in to complete the square? How much? 1. 7 plus 1. I should put in number 2, right? If I put in the number 2, then what is the total area now? I mean, it's not drawn to scale. If I put in 2 more squares, you'll be able to get 9 squares, isn't it? And therefore, you can form a perfect square. Can you tell me how much is the length over here? How much? 3 and 3. This action of introducing the number 2 is called completing the square. Okay? Okay, let me try another example. Let us try with the number 15. Again, it is not a perfect square. I end up with a missing bit. What is the number I should introduce in order to make it a perfect square? 1. Okay, very good. Put a 1 over here. I introduce the number 1. How much is the length over here now? 4. And this one? 4. Okay? So if you look at these 2 examples, what I have been doing is, the original question 7, I add 2. Right? I added 2 and I get a perfect square. Okay? In this example, 15, I added 1 and I got a perfect square. Okay? This process is called completing the square. Anybody lost? Need to follow. Next part is the algebra already. Okay? Now we have, for example, x plus 3 squared. What does this look like in a diagram? Let me show you. Okay, I have a big square. It is made out of a square over here. Sides dimensions x by x. What is the area inside this square here? X square lah. Okay, and then this side I have 3, and its height is now x. How much is the area here? 3x. What about this one? It's the same, right? 3x. What about this one? How much? 3 times 3, right? This is over 3, this is 3. So this is 3 squared, which is 9, isn't it? Right? Okay. Do you realize that this is the pictorial representation of x plus 3 squared? You notice that the length of this square is x plus 3. And then the breadth is also x plus 3. That is x plus 3 squared. Mathematically, if I work it out, this is equals to x squared plus 3x plus 3x plus 3 squared. Correct? I'm just adding up all the areas inside. Follow so far? Okay, so this is x squared plus 6x plus 9. That is our formula that we are very familiar with. Pictorially, it looks like this. Okay? Now, this is an example of a perfect square. What if you are given something that is not a perfect square? For example, x squared plus 5x. Okay, let us take a look at this one. Pictorially, it looks like this. X and x. Then I add this one over here, 5. This is x. Okay, so far? X squared plus 5x. So this is equals to x squared plus 5x. Now I'm going to do some adjustments to this rectangle over here. I'm going to chop it into 2 equal parts because my objective is to form a perfect square. Let's see how I can change this rectangle to create a perfect square. So if I divide this into 2 equal parts, I will have 2 strips. Can you tell me how much this is? 5 over 2. How much is this? Also 5 over 2. Now I'm going to separate them. I'm going to rearrange my picture. So this is still x and x. Then I put one piece over here, and I put one piece over here. Over here I have 5 over 2, and over here I have 5 over 2. Are they the same diagram? I didn't change the area, right? Did I change the area? No, still the same thing. So in other words, this is still a diagram of x squared plus 5x. Right? They are the same thing. Now, question, is this a perfect square? Is this a perfect square? No, right? What do we need to add to make it a perfect square? Remember our previous examples? We knew what numbers to add, right? To make it a perfect square. So right now, what should I add to make it a perfect square? It is going to be found here. This bit, isn't it? What is the area of this little square here? Okay, you should realize that this is still 5 over 2 and 5 over 2. So if I add this square over here, 5 over 2, I will be able to make it a perfect square, right? Okay, so let me redraw it. Okay, at the bottom, so you still can see, originally, x, one piece. This is 5 over 2. This one also 5 over 2. And we want to add 5 over 2 square. Okay, this is 5 over 2 square. Now, my diagram has changed. Now, I have a diagram of x squared plus 5x plus 5 over 2 square. Right, this is now what my diagram is representing. Are these two the same? Are they equivalent? No, they are not equivalent. They are different now. What changed? I added this bit. I added a 5 over 2 square by myself. So they are no longer the same. Okay, next part. How do we get from here to here? Because originally my question was x squared plus 5x. So how do I get from this step to my original question. What do I need to do? What do I need to do? Everybody think about it. What do I need to do to get from x squared plus 5x plus 5 over 2 squared back to my original expression of x squared plus 5x? Minus what? I need to minus 5 over 2 squared. Then I'll get back my original expression, isn't it? Okay, so from here to here, all I need to do is to just subtract away what I added by myself. Okay? Anybody lost at this point? Don't be shy, Anybody lost? Okay, at which step do you need clarification? Is this part okay? Okay, then from here, do you know why I added a 5 over 2 square? So that I can make a complete square, isn't it? So now this diagram, I've got over here x squared. Over here, the blue color side, 5 over 2x plus 5 over 2x, I get 5x. Then I added this red color bit, which is 5 over 2 squared. Okay, now this is a complete square. You see it? Original question, it is not a completed square. After I added the red color piece, it became a complete square. But at the same time, I changed the question. I cannot anyhow change the question whenever I want to. So to go back to the original expression, what I needed to do was to take away what I added in, which is minus away 5 over 2 squared. Okay? Okay, what's the point of doing all this? In summary, what I have now is x squared plus 5 over 2, x squared plus 5x. In summary, x squared plus 5x, then I add 5 over 2 square, I remove it again. I will get my original equation, x squared plus 5x. Okay? Quite intuitive, right? See all the black parts, they are the same. All I did was to introduce 5 over 2 square, and then I take it out again. Of course, they are going to be equal. But what is the point of doing all this is that this red color one was the piece that I added to make it a complete square. So where is my completed square? This is my completed square. And what is the completed square over here? X plus 5 over 2. Yeah. This is x plus 5 over 2 square. Right? X squared plus 5x plus 5 over 2 square. This is actually x plus 5 over 2 square. We can see it from the dimensions in this square. This is x plus 5 over 2 multiplied by x plus 5 over 2. We square it. We will get x squared plus 5x plus 5 over 2 square. We transfer it over here. Aren't they the same thing? Same thing, right? So this is my completed square. Then what am I left with? The red color piece. Then I have to subtract it. 5 over 2 square. This is equals to x squared plus 5x. Okay? So this is known as the process of completing the square. Alright. Let us try some examples to fully understand what is happening. Okay, one example over here, I've got x squared plus 8x. Is it a complete square? Is it a complete square? Can I express it as something plus something, x plus something square? You won't be able to. Okay, that is why we will need to introduce a term. Then I need to remove the term again so that I do not change the question. So these are the steps. First, we identify the coefficient of x. What is the coefficient of x? 8. It is a positive 8. So over here, I will take x squared plus 8x. I don't change anything yet. Now I will add in the missing piece. What is my missing piece? Do you remember how to find the missing piece? What did I do to get my missing piece over here? I divided by 2. 5 divided by 2. The coefficient of x over here, I divide by 2 to get a missing piece. So here coefficient of x is 8. So 8 divided by 2. Is it just like that, or do I have to square it? Square it. The missing piece is a square. So 8 over 2 square. Now, have I changed the question so far? See, this is my original question. Is it still the same? They are no longer the same. I am not allowed to change the question. So what must I do? I need to remove it again. Okay? Okay, what's the point of doing all this? Because this gives me a perfect square. And what is this perfect square? It is x plus 8 over 2 square. Then I still have minus 8 over 2 square. Okay, we're going to highlight some important parts. See the 8 over 2? Do you see why I have 8 over 2? It came from the coefficient of x. Yes? Why minus 8 over 2 square? Okay, rewind. Rewind. Now, do you understand this step so far? Are they equal? Are you sure they are equal? What is the difference? Yeah, over here I added the red color part myself. I added it myself. Right? So they cannot be equal anymore. So what must I do to make them equal? Okay. So take away 8 over 2 square. So now they are equal because they cancel each other out. Okay? Now, as I was saying that these are the same. This is a complete square. And I'll get x, I use blue color, plus 8 over 2 square and minus 8 over 2 square. Now, we don't leave our answers like this. We need to evaluate further. So my answer will be x plus 4 square minus 16. Okay? Shall we check our answers? Do you really think that x squared plus 8x is really equals to this? Do you really believe it? How do we check? Just expand this. Okay? Side working. My side working. X plus 4 square minus 16. How much is that? X squared plus 2 times x. 4 plus 4 square minus 16. What do I have? X squared plus 8x. Hey, they cancel each other out. Plus 16 minus 16. This is x squared plus 8x. You see? It's the same. Okay? So, what have I done? Originally, this was what I was given. X squared plus 8x. I added in a term. I subtract the term. I choose the first 3 terms to combine into a perfect square. Then I find out what is the remainder, which is negative 16. And they are still equivalent. Okay? Any questions so far? Otherwise, let me try another example with you. X squared minus 7x. Now, always identify what is your coefficient of x. What is the coefficient of x? Ziling? Ziling? Yeah, what's the coefficient of x? 7. Who disagrees that it is 7? Anybody disagree? Yes, can you tell us why you disagree? Okay, so, class, is the coefficient of x 7 or negative 7? Negative 7, okay, Ziling? Remember, there's a negative sign. Let us not forget it. Okay, highlight the coefficient of x in your question. Now next, we are going to write down x squared minus 7x. It is not a complete square yet. What do I need to add? I need to add a missing piece. What is the missing piece? The missing piece is always the coefficient of x divided by 2, and then we square it. What is the coefficient of x? Still 7. Negative 7 divided by 2, we square it. Now, are they equal? Is my equation correct? It is not correct. What do I need to do? Minus what? Negative 7 over 2 square. What's the point of doing this? Because my first 3 terms, they give me a perfect square. And how much is that? This is x minus 7 over 2 square minus negative 7 over 2 square. Okay, let me highlight the key parts. Notice that in my perfect square, I've got a negative sign this time. It came from the negative sign of coefficient of x. Can? Let us simplify. Simplify shouldn't be a problem for your class. Now I have x minus 7 over 2 square minus 49 over 4. Okay? Want to check? Yes. If you change to decimal, what do you get? 3/5. Generally, we don't use decimals in algebra. It may be confusing. So we always leave it as fractions in algebra. Okay? And we do not have to evaluate this 49 over 4 as well. Just leave it as 49 over 4. Okay. I leave it to you to check whether they are equivalent. Of course they are lah. But you can go and check and convince yourself. So what have we learned from all of this? It can be summarized into one single equation or expression. In general, x squared plus bx is equals to x squared plus bx. Then I add, what do I add? Coefficient of x divided by 2 square. B over 2 square, and I need to remove it again. Okay? And what's the point of doing all this? Because my first 3 terms give me a perfect square. That means x plus b over 2 square, and I subtract b over 2 square. This is what we need to learn from this lesson. Please take note that b can be positive or negative. Okay? I'll show you 2 examples, one with positive b, one with negative b. Okay, so this is the process of completing the square. Is this too much? Is this too much for anybody? Please sound out. Okay, then let's go into example number 9 of your textbook, page 49. Notice the phrasing of the question, it looks strange. Express each of the following in the form something plus something square plus k, where h and k are constants. Nowhere did they mention about completing the square, but you are expected to realize that this is a completing the square question. Right? We have a perfect square. That is called x plus h squared. Let's take a look at question A. X squared plus 10x minus 3. Okay, let us express it into the form of x plus h squared plus k. These two are constants. Yes? I can't hear you. Page 49. Hey, that's very rude. Huh? Okay, so to express it in this form, we will have to complete the square. Okay, so completing a square, x squared plus 10x. Hey, what about this negative 3 over here? Remember in our previous examples, we always have 2 terms only, x squared plus or minus something x. X squared plus or minus something x. Right now in our question, they gave you another constant, minus 3. How? Don't worry. Let us just put it at the back. We are familiar with how to complete the square for this. Right? We know how to complete the square for x squared plus 10x. But it's this negative 3 over here that is causing some problems for us. Don't worry. Put it at the back. Okay? So whatever over here is still our complete the square. Complete the square. Okay? And then the negative 3 is still here. Don't worry. Can? Now let us use our steps that we have learned to complete the square for this part. First thing we need to do is to just simply copy down x squared plus 10x. Okay, so far? Are they still equal? Yes, they are still equal. What do I need to introduce to complete the square? Find out what is my coefficient of x. Positive 10, yes, very good. So I need to introduce 10 over 2 square. What else do I need to do? Minus it away. Minus 10 over 2 square. Okay? Now, we don't need these red boxes to help us already. Where is my completed square? Which terms are they? These 3 terms give me my completed square, isn't it? This is x plus 10 over 2 square minus 10 over 2 square minus 3. Okay? Let's continue. This will be x plus 5 square minus 25 minus 3. Okay, this is what I have so far. Is this of the form? Remember our original question, they wanted us to express it in the form of x plus h square plus k. Are they in a, is this the correct format? Is it the correct format? Yes, right. What is the value of h? If I ask you, h equals to? 5, okay. What about k? Negative 28. Please take note that h and k, they are constants. They can be positive and, okay, or negative. Okay? Don't worry if your numbers are negative, it's okay. Alright, let's try another question, part B, where we have a negative sign. Still on example 9, B, x squared minus 7x plus 4 equals to, so again, we only know how to complete the square for these 2 terms. So leave a blank, plus 4 over here. Now let us complete the square. So one more demonstration and you'll be solving the rest yourself. Copy down the first 2 terms, x squared minus 7x. Highlight your coefficient of x, which is negative 7. What is the number that I need to add in order to complete the square? Negative 7 over 2. Now we don't need this anymore. Okay? The first 3 terms will give us the completed square. Is it plus or minus? X plus or minus 7 over 2? Who is lost? Lost? Raise your hand. Okay. Do you understand why I'm adding this and subtracting it at the same time? Okay, we are completing a square. That is the first step. And the process of completing a square, the very first 3 terms, this is our completed square. Right? We have seen the diagram like this. So this is my completed square. It will be simplified to become x minus 7 over 2 square. Okay? Next, we still have a few more terms. Minus negative 7 over 2 square and plus 4. So now we continue to simplify. Here, from here on, it's just basic algebra, no problem already. Equals to x minus 7 over 2 square minus 49 over 4 plus 4. Okay, then we will get x minus 7 over 2 square minus 33 over 4. That's the answer. Okay, just simplifying only. The next part is nothing scary. All that, the difficult part is already over. Okay? Next is solving equations. Remember, the first portion of the lesson, we said we want to change it into a perfect square so that we can solve it, right? Because some of them cannot be solved by factorization. So now that we have learned how to complete the square, let's see how we can apply it to solve equations. For example, let's look at example 11. Example 11, we have x squared minus x minus 3 equals to 0. This is on page 51. Now, if you went into the exam, if you go into the exam, you see this question, and your first instinct, what is it? Try and factorize, isn't it? Then you realize that you cannot factorize it. Then how? Use completing the square, okay? So the steps are as follows. From here, we shift this negative 3 over to the other side. And when I say we shift, I mean we add 3 onto both sides. Plus 3, and over here, plus 3. So I end up with x squared minus x equals to 3. Simple, straightforward. Now, I need to complete the square. Look at this over here. Is it a perfect square yet? Is it a perfect square? No, it is not. I need to complete the square, and I need the coefficient of x. What is the coefficient of x? 1? Is it 1? Is the coefficient of x 1? Or is it negative 1? Still falling into the trap, some of you. It is negative 1 over here. So that's why I encourage you to take a highlighter, go and highlight the coefficient of x, including the sign. Because a wrong sign will result in a wrong answer. So the coefficient of x is negative 1. Next step, I have x squared minus x. Now I'm going to introduce in plus negative 1 over 2 square. I remove it again, negative 1 over 2 square. And what is this supposed to give me? What is this equal to? 3 lah. Okay? Did I change the question? No, I didn't. But I introduced one term, I removed the term. So I didn't change the question. And what's the point of doing all this? Because this gives me a perfect square. Okay, if you want to continue with the highlighting, this is what you highlight. Okay? Now, the perfect square looks like this. X minus 1 over 2 square minus negative 1 over 2, correct. And this is equals to 3. Very easy from here on already. All you need to do is to just simplify. Here we have already completed the square. And that is a requirement in the question. By completing the square, solve. Okay, I've completed the square. Let's see how this makes my life easier. Next step, x minus half square minus 1 over 4 equals to 3. X minus half square equals to 3 and 1/4, which is 13 over 4. Right? This is what we want to see. This is what we want. Because it becomes very easy to solve this. What do we need to do to solve for x? What do we need to do to solve for x at this point in time? Square root both sides. Exactly. Remember the start of the lesson, I also show you how it is easy to solve this. Don't forget, just take square root both sides. And what am I left with? Therefore, x minus half is equals to plus minus square root 13 over 4. Okay? Then x is going to be equals to half plus square root 13 over 4, or half minus square root 13 over 4. Okay? Two answers. Now in Emaths, do we deal with surds in Emaths? Surds, remember surds? We don't leave our answers with square root and all these kind of things. In Emaths, we round off our answers to 3SF. Okay? These are irrational numbers. So get an answer, then you round it off. Your final answer should be 2.30 or negative 1.30. Okay? Any questions? So this is the application of using completing the square to solve an equation. Okay? Everything else is the same already. Can? Last 5 minutes, I want you to try it 11.